students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NIT-JEE graduate. So bring out your books. Let's make your preparation stress-free. Hello students, this is Anmol Yadav from Sri Gurukula Academy and I am your physics and mathematics mentor. From today onwards, we are going to start a series of videos to help you prepare better for your competitive exams. So the aim of these videos will be to quickly revise the concepts which we require to solve the questions, and we will try to solve some questions. And in today's video, we will start kinematics, which is a study of motion without cause. In kinematics, we have two parts, motion in a straight line and a motion in a plane. And in today's video, we will specifically focus on a motion in a straight line. So let's start today's video. So motion in a straight line in kinematics, the very basics of this chapter is to study about displacement, velocity and acceleration. Now what is velocity? First we study about average velocity. Average velocity is total displacement divided by total time. And similarly we have average acceleration, which is total velocity by total time. Correct? And we have instantaneous velocity and instantaneous acceleration. Instantaneous velocity is simply denoted by v, and it is equals to differentiation of x with respect to time, which is dx by dt, and instantaneous acceleration is dv by dt. Correct? Now for acceleration we can write one more formula in terms of v and x. How? What we will do, we will multiply. We can write dv by dt is equals to like this. Dx by dx is still 1, correct? So we can write this as this, and if you will notice this term dx by dt, what is dx by dt? It is velocity, means acceleration can also be written as velocity into dv by dx, dv by dx. So these are few formulas, important formulas, or we can say these are the basics of motion in a straight line. So through this basics only, we will derive all the formulas that you have studied in this chapter, like for a height, for a tower questions, or for car questions, for everything, for all the formulas, even the motion, that three formula for motion of a constant acceleration has also been derived from these things only. So these three equations are the very basics of this chapter. Now if you will observe these two equations, there is one important thing that I want to tell. See, this is displacement, velocity and acceleration. Important thing is, when you are differentiating x with respect to time, we are getting velocity. So differentiation with respect to time of displacement will give us velocity. Displacement of velocity, differentiation of velocity with respect to time, differentiation of velocity with respect to time will give us acceleration. See, differentiation of velocity with respect to time is the acceleration. Now in the same formulas, if you see this acceleration formula, I can write dv is equals to a dt, and integration of acceleration with respect to time is giving us a velocity, means integration of acceleration with respect to time is giving us velocity, and similarly integration of velocity with respect to time will give us displacement. So this is the concept that we require. So this is the basic formula that we require, and this is the concept that we require to use with these formulas to solve each and every question. So if you don't know anything, any formula after this, like in motion in a straight line, if you know these two things, I guarantee you can solve each and every question of motion in a straight line, because all those formulas have been derived from these two concepts only. Now the major part of this chapter, we study about motion which has a constant acceleration. So if we assume for a is equals to constant, so when acceleration is equals to constant, we get our three equation of motion, which are ut, v is equals to u plus at, s is equals to ut plus half at square, and v square minus u square is equals to 2as. These three formulas can also be derived from these two things, using these two things. So if you if you will use A is equals to V dV by dx and you will integrate that formula, you will get this formula. Similarly, if you will integrate V is equals to dx by dt, if you will integrate V is equals to, if you will integrate A is equals to dV by dt, you will get this formula. And if you will integrate V is equals to dx by dt, you will get this formula. So just by doing integration of all these three formulas, integration of these three formulas will give us these three formulas, correct? Now, another one important formula there in this chapter is displacement at nth second. Displacement at nth second, if you have studied the formula, it is u plus a by 2 into 2n minus 1. Sir, what we will do if we don't remember this formula? So if you don't remember this formula, you remember the concept. What is the concept behind displacement at nth second? So let's suppose a vehicle is moving this much distance in n seconds. So what will be the displacement in nth second? So let's suppose this is the distance traveled by vehicle in n minus 1 second. So this is Sn and this is Sn minus 1. So what will be the displacement in nth second? Snth. It will be Sn minus 1. So displacement in nth second is displacement in n seconds minus displacement in n minus 1 second. So if you don't remember the formula, you remember the concept as well. You can simply use this concept to solve the question as well, correct? Now, these are the important concepts and there are some golden rules as well. Using all these three formulas, which is the V is equals to dx by dt and A is equals to dV by dt, correct? So there are four golden rules or four important lines that you should remember. That is slope. This is important to understand the graph of all the curves. So slope of a displacement and time curve. See, slope of displacement time means dx by dt is giving us velocity. So slope of displacement time curve gives velocity. Similarly, slope of velocity time curve will give acceleration. And if you know this formula, if you can write dx is equals to v dt and integrate this, and we can write dv is equals to a dt and integrate this, correct? So this is multiplication of two dimensions. This is multiplication of velocity and time dimension, and this is multiplication of acceleration dimension and time dimension. So multiplication of two dimension gives us a area. It means area of velocity time curve, or area under velocity time curve will give displacement. And similarly, area under acceleration time curve will give us velocity. So these are the important concepts that we require to solve each and every competitive question for motion in a straight line. And now we will start solving few questions. Let's see our first question. So our first question is: a particle is moving along x-axis with its position x varying with time t as x is equals to alpha t to the power 4 plus beta t square plus gamma t plus delta. The ratio of its initial velocity to its initial acceleration respectively is. Means we need initial velocity, we need initial acceleration, and we need its ratio. So first we are supposed to find velocity at t is equals to 0. We'll find velocity and we'll put t is equals to 0. Similarly, we'll find acceleration and we will put t is equals to 0, and then we'll take the ratio, correct? Now we have displacement in terms of time. So we know velocity is equals to dx by dt, means differentiation of x with respect to time. So let's differentiate this with respect to time. So differentiation of alpha t to the power 4 will be 4 times alpha t square t cube, correct? Everyone can do this simple differentiation, I guess, right? Now similarly, differentiation of beta t square, beta is constant, and differentiation of t square is 2t, so 2t. Differentiation of gamma t will be gamma, and differentiation of constant delta will be 0 plus 0, correct? Now this is the velocity at any time t. So velocity at t is equals to 0. Velocity at t is equals to 0 means let's put t is equals to 0 here. So if t is equals to 0 means this term will become 0, this term will become 0. Only term we are left with is gamma. So velocity at t is equals to 0 is gamma. Now we need acceleration at t is equals to 0 as well. Now acceleration formula we know, it is dv by dt, just we studied, correct? Means differentiation of velocity with respect to time. So velocity we have in terms of time. Let's differentiate this again with respect to time. So what we will get? 4 alpha is constant and differentiation of t cube will be 3t square. So 3 into 4 will become 12 alpha t square. Now differentiation of 2 beta t. 2 beta is constant and differentiation of t is 1. Differentiation of gamma will be 0 plus 0. Now we need acceleration at t is equals to 0. So let's put t is equals to 0 here. The only term we are left with is 2 beta. Now we need ratio of this two. So ratio of this two will be gamma is to 2 beta. Do we have any option gamma is to 2 beta? Yes, our option D is the correct option. Understood? Now let's see another question. In this question we have a bullet from a gun is fired on a rectangular wooden block with velocity u. So while reading the question, what we will do? We will try to make the diagram. Okay. So we have, from this question we understood we have a gun. We have a gun, not very beautiful, but it is a gun, correct? And this is the bullet. Beautiful bullet, right? And this is moving with the velocity. This is moving with the velocity u, correct? So this is what we understood with the first statement. Now let's read the question further. When we have another wooden block as well. So this bullet has been fired towards a wooden block. This is, let's suppose this is our wooden block and velocity is u. Now when bullet travels 24 centimeter through the block along its length horizontally. So this bullet will go here and it will go inside the block and it will travel 24 centimeters. So let's suppose this is our 24 centimeters. This is our 24 centimeters. So initially the velocity is u, and when it traveled 24 centimeters, the velocity of the bullet became u by 3. So at this point, the velocity of bullet is given as u by 3. Then it further penetrates into the block in the same direction. Now see, bullet is going in this direction, and they are telling it is still going in this direction. So it is further penetrating into the block in the same direction before it comes to rest. Means finally it is coming to rest, means final velocity will be 0 exactly at the other end. Means it is coming at rest exactly at the other end. Means at this point the velocity is equals to 0, correct? Exactly at the other end of the block. Now the total length of the block is, they are asking this total length of the block. So let's assume this length be L. Okay, so we have assumed this length as L. So now we are supposed to study this entire thing in 2 intervals. First interval when bullet is traveling from here to here, from point A to B, and then from B to C. So first from A to B. What things we know? How we will decide which formula we are supposed to use? So we will see what things we know already. So we know displacement in this interval from A to B. We have initial velocity, we have final velocity. And what we need, and we understood that this bullet is slowing down. See, initial the velocity was more, final the velocity reduced. Means some deceleration is there, correct? So we have initial velocity, final velocity, and displacement. Which formula we can use? Which have all these three. S is equals to ut plus half at square. It don't have final velocity, right? V is equals to u plus at. It don't have displacement. But v square minus u square is equals to 2as. It contains all these three things: displacement as well, initial velocity as well, and final velocity as well. So this is the formula we will use in interval A to B. Now what is the final velocity? So in this interval, final thing is it is reaching at B. In this event from A to B, what is the final event? Final event when bullet is reaching at B. So final velocity will be u by 3. Means square will be u square by 9. minus u square. Initial velocity is means velocity at a, which is u. So this will be u square is equals to, now 2 times acceleration. Let's suppose acceleration is in this direction, correct? Since velocity is reducing, means acceleration is in opposite direction, correct? So it is deceleration. Let's suppose it is minus a. Let's suppose it is, why minus? Because it is in the opposite direction. See, bullet is moving in this direction and acceleration in this direction. So they are in opposite direction, correct? That's why it is minus a, since it is a retardation. Now we know displacement as well. What is the displacement? 24 centimeters. 24 centimeters. So using this formula we can find a. So a will be equals to, let's take it as u square into minus 8 by 9 is equals to minus a into 48. Now this will become so now here we have this minus and minus sign will cancel out. Acceleration will be equals to, this is 8 ones are and 8 six are. So acceleration will be equals to u square by 9 six are 54. So this is our acceleration in terms of u. Now we'll study from event B to C, when bullet is traveling from B to C. So from B to C, again we know final velocity, we know initial velocity, we have acceleration. Any formula that all these three things are present, final velocity, initial velocity and acceleration, again the same formula, which is v square minus u square is equals to 2as. But this time conditions are different. What is our final thing? Final velocity. Finally the bullet came at rest. So final velocity is 0. Initial velocity for this event from B to C, initial velocity is u by 3, means minus u square by 9. Square of u by 3 will be u square by 9 is equals to 2 times acceleration. Acceleration again it is retardation, so it will be minus sign, and amount is u square by 54. And what is the displacement here? So this entire length is L and this is 24. So this length will be L minus 24, correct? So this will be L minus 24. Now see this 0 we can remove simply. So this negative sign will cancel out. U square cancel out. 9 ones are 9 six are, correct? 2 ones are and 2 threes are. So 3 will go on the other side, is equals to L minus 24. So 3 is equals to L minus 24. So L is equals to 24 plus 3, which is 27 centimeters. So L is equals to 27 centimeters. Any option we have? Yes, option D is the correct option. Correct? Now let's see another question. A graph question, correct? I already told you about the graph as well. So the velocity time plot of a motion of a body is shown below. So this is a velocity time curve. So acceleration time graph of that best suits the motion is. So which of this acceleration time graph is describing this velocity time graph? Now I said you acceleration is equals to dv by dt, means acceleration is slope of velocity time curve. So let's see slope in this interval. Let's take this point as O, A, B, C and D. So from O to A, slope of the curve is 0, means acceleration should be 0. So first from A to B, the acceleration should be 0. Everywhere initial acceleration is 0. Now from A to B you will see the slope is constant. The slope is constant, the entire slope is constant. Slope constant means acceleration constant, means acceleration from A to B is not changing, same value. See here acceleration increasing, so this is the incorrect option. See here acceleration increasing, incorrect option. See here acceleration constant, so this can be our correct option. See here acceleration constant but negative. See here positive slope means positive acceleration, so this is also incorrect option. This is the only correct option. Now let's see further case as well. See from B to C slope is 0. Slope is 0 means acceleration 0. From C to D slope is constant but negative. Constant but negative. Correct. So C is our correct option. Now next question we have, a small block slides down on a smooth inclined plane starting from rest at t is equals to 0. So from this question we understood there is an inclined plane. Let's suppose this angle theta, a block is going down, correct? At t is equals to 0, the block has been released. Then Sn be the distance traveled by the block in the interval t is equals to n minus 1 to t is equals to n, means last at the nth second. This Sn donates the nth second displacement at nth second, then the ratio of Sn divided by Sn minus Sn plus 1. So we need Sn divided by Sn plus 1. Now we know the formula for Sn. Sn is equals to u plus a by 2 into 2n minus 1. Correct? This is the Sn formula. Now what is the formula for Sn plus 1? Simply wherever we have n, we put n plus 1. Correct? So this will be equals to u plus a by 2 into 2 into n plus 1 minus 1. So this will be equals to, and if you will see, the block has been starting from rest. So block is starting from rest, means initial velocity will be 0. Initial velocity will be 0. Now Sn plus 1 is equals to a by 2. Let's open this bracket. So 2n plus 2 minus 1. So this will be equals to a by 2 into 2n plus 1. Now we need the ratio of these two. So Sn so we need Sn divided by Sn plus 1. It is equals to a by 2 into 2n minus 1 divided by a by 2 into 2n plus 1. So a by 2 cancel out. 2n minus 1 divided by 2n plus 1. Option B is the correct answer. So this is our final question for today. A body drops from top of a tower, falls through 40 centimeter during the last 2 seconds of its fall. The height of the tower is. So this is very good question. So let's assume we have a tower. So let's suppose this is our tower. Let's suppose the height is h. Okay. So a body has been dropped, means initial velocity. Body is dropped from here, means initial velocity is 0. And in last 2 seconds, let's suppose it traveled this distance. Correct? In last 2 seconds, what is the question? It is traveling 40 meters. It is traveling 40 meters in last 2 seconds. So this interval is 2 seconds. Correct? Now what will be the height of the tower? So again we have two cases, from here to here and from here to here. Okay. So let's suppose when block is reaching here, the velocity is v. Let's suppose when block is reaching here, the velocity is v. So from here to here, from here to below, the time taken is 2 seconds, and displacement we know, and initial velocity we know. So this is our point A, point B, and point C. So from B to C, let's see only this interval. Now this is our case. Initial velocity is v, final velocity will be something that we don't know. We know height, we know time. So any formula, distance, displacement we know, time we know, and initial velocity we know. So formula for that we will use is S is equals to ut plus half at square. Why we are using this? Because we know displacement. Yes, we know displacement. We know time. We know initial velocity, which we have assumed unknown, but we know acceleration, which is minus g. Correct? So we will use this formula from B to C. So S is equals to 40 is equals to initial velocity we assumed as v. So v and time taken is 2 seconds plus half into acceleration is g, and t square means 2 square. So this 2 will cancel out, and 40 is equals to 2v plus 2g, and g is equals to 10, means this is 20. So 2v is equals to 40 minus 20 will be 20, and v is equals to 10 meters per second. So velocity at this point is equals to 10 meters per second. Correct? Now Now another case we have is from point A to B. So if this is 40, this is h, so this height will be h minus 40. H minus 40. Now we know initial velocity, we know final velocity, we know displacement, we know acceleration. Which formula we should use? From A to B. Initial velocity, final velocity, acceleration and displacement. So v square minus u square is equals to 2as. Initial velocity known, final velocity known, acceleration known, displacement known. Correct? Now let's use this formula. So final velocity is 10. 10 square will be 100. Initial velocity is 0 is equals to 2 times acceleration is 10 and displacement is h minus 40. So let's remove this 0. 1 0 and 1 0 will cancel out. 2 1s are and 2 5s are. So 40 h minus 40. H minus 40 is equals to 5. H minus 40 is equals to 5 means h is equals to 45 meters. So correct option will be 45 is the B option. Means B is our correct answer. So this is all for today, students. If you have any doubt, please drop into the comment section. And if you want me to explain some more concepts from this chapter, and if you have doubt in some question, please tell us in our comment section. I will try to make a video on that as well soon. And from next lecture, I will start motion in a plane. So stay tuned for our next video.